how to structure your computer programs and clearly communicate their internal architecture. You have to use some of the highest level abstractions that are accepted as the norm, and not just in the world of programming, but also in the large world of interacting with computers. The more popular the concept, the clearer the picture it will paint. Rather than using the concept of object programming, or stream programming, or transducers, or transformers, and then conventions and configurations and constants, you introduce the concept of the virtual file system. And right at the center of your program, folders, files, inodes, mount points, everything. You don't use the concept of data objects, but virtual files that you can then smash together to assemble virtual file systems. These files can have a toObject or toBuffer or toString function where you convert them from one convenient shape to another. You can have a series of services that you start and stop. You can even have a virtual desktop. Whichever of these large, well-known concepts fit your program, use them. And use them wisely so that they don't cause any problems or slow anything down or get in the way of the program. Countless critics will come, of course, and accuse you of leaky abstractions and overprogramming, if not downright overkill. But listen to what they are talking about. You are arguing about internal architecture of your program with strangers who successfully understood it without knowing much about it. If your program manager asks you why you can telnet into the web page and access admin settings through a text user interface, you tell him it is because you like to bask in the gross incandescence of arrogant strangers simply grokking the internal architecture of your apps. It is a way of getting all the contributors to know just how your program works. And you can no doubt sense room for innovations here, and that is true. The next version of world's most useful operating system was going to parade the concept of everything is a file. You can see that in your proc directory where the temperature of your CPU is a file, which is compatible with all the programs. You don't need to do anything special to read temperature. You just open the file and get the number out. To give a somewhat convoluted example, I was writing a tiny visual programming language where you drag and drop program parts together, and I identified a large problem in the Oort cloud surrounding it. Where will be my visual programming language installed? Where will it do its thing the best way it can? And my first idea was Electron, a browser-based application framework. But then I thought of web browser plugins and a proper little server. And although these ideas are fun and very useful, they are weak. The question really remained unanswered. Let's imagine we have a visual programming language where you can drag and drop things together to create stuff. You create a program, and what do you do to run it? Do you need to bundle it along with the visual programming language? That would not be very good. The answer that I was looking for was in code generation, Lots of code templates stacked together to make code that is indistinguishable from code that an average programmer would write. And code belongs in files. And because we deal with the web, the code will have to be put into something like a file. Let's call it a custom file, a virtual file, that is then put into a custom virtual file system. And all of this is still happening in the browser, and this custom little file system is then translated into a zip file. You download the zip file from the web page, just like you would download a zip file from your favorite application place, extract it, and inside the resulting folder will be all the files that your code created. And it has no need for the virtual programming language at all. It's indistinguishable from normal programmer code. Perfect. Now, allow me to demonstrate the medium level of abstraction versus the topmost level of abstraction, the difference in clarity. Here is a clear but wordy explanation. Think of a double-decker architecture. We have a file world above. Yeah, that's where the files live. Where files generated by programs are routed into file systems. Sometimes file systems are mounted on top of other file systems via mount points. But ultimately, a zip file is created, and that is how a virtual file becomes a real file. It is downloaded to the disk and extracted. This file world is above application builders or visual programming languages. Those live on a conceptual layer beneath. Most application builders and visual programming languages won't have a real clear concept of a file. They are drag and drop visual interfaces after all. They are an abstraction layer or two above files. But every application builder or visual programming language or design environment of any kind will generate files that are then pushed up into the file world above, routed around, and eventually make their way into that final zip file. Sounds okay, kind of, and it sort of makes sense. Files above, drag and drop based UI beneath. Now, let me explain this to you on a more friendly, larger conceptual level that to some people would seem like being bloated or including too many things that aren't necessary. But look how much cleaner the explanation. Each environment lives in a virtual desktop window. You can manually save your project and also generate the files by simply clicking export, usually something done automatically when exporting your entire project into a zip. You can contrast this two-paragraph explanation with the one above and see how much simpler and more powerful it is. You just need to find the right high-level concepts to put in your program, and your architecture will speak for itself. Just imagine how this simplifies documentation. The concept of files is also a very powerful conceptual bookmark, even to people familiar with the internal architecture of the entire system. Thus, we can now unify many application builders without any confusion whatsoever, and even inject files from one visual creator to another. You may inject a logo created by an AI-based graphic generator into your Bento Box website project, and the image will then make it into the final zip file when the project is generated. A Bento Box website builder is where you have a complex animated page layout that you can't ruin, as it only allows you to drop text and images into very specific preset places or user editable zones. Now, what used to be a visual programming language that didn't make it clear where it or its programs would run is a desktop environment, or a zooming user interface in my case, where various types of visual editors send out just files that are then moved around as a whole and sent out as a monorepository into a zip file. Finally, all of this can be done with object-oriented programming or even functional programming as well. Yes, it would be compact, smaller, and more efficient, but also more packed, needing far more documentation and developer guidance, and a lot of little conventions. Architecture is large, luscious, painted with broad brush strokes, and unlike the smaller and more compact, good architecture is immediately understandable. It's obvious. It can be intuited. If someone wants to bring in a new visual programming language to my platform, then they just need to figure out how to generate files and make a new window. They grok the platform instantly, precisely because it is not just object-oriented programming or just functional reactive programming, but it is large, luscious concepts. And that is good and clear architectural design. Lastly, you would think that such things would ruin network card drivers or efficient GPU code. But in places that demand shortest set of instructions possible, good architecture drifts into the code editors, into all the tools, debuggers, and decompilers. Hexadecimal data is broken down by patterns and lit up with various colors. Program branching is captured with arrows. File panes become concept maps. And hey, maybe, if the world is ready for it, code editor plugins are a little bit more like browser windows, where you get to write your own user interface for your own program that matches it exactly, and then it sits right next to your code editor. In general, you still get efficient code without the bloat, but the developer experience is nothing short of luxury. A somewhat rough, though beautiful example of luxury is found in the world of 3D game development, which also demands efficiency. You can have your developers program the game outside in, or have them program a live editor, where they are placed into the unfinished game and can design it inside out. They are not playing the game. It is not the final game. It is a 3D level editor, a luxury tool where they sculpt the game inside out. This will not make the final game slower. It will make it more beautiful. The level editor may remain an internal tool. We moved from the low-level concept of programming walls and characters to the high-level one of sculpting them with a pen and tablet or mouse right within an environment that looks exactly like the game. I would argue that high-level abstractions at the center of your program have nothing to do with bloat or leaky abstraction, and have everything to do with being the beating heart of your application, so that you know you can always come back and do upgrades and fixes without any of the usual frustrations of upgrading large programs.